Let's walk through the quiz review for chapter 2.2 to 2.3. So this is going to cover power rule, um, product rule, chain rule, as well as PVA. So let's look at number one. The velocity of a function is described by the function v of t. And here is our velocity function. So for part A, find the time when acceleration is 0. So first thing we need to do is we need to find the acceleration function. So we need to find the derivative for velocity. We're going to go through power rule. So power rule, we're going to bring down the 3 in front. So I have the step, the first step here, bring down the 3. Keep the 1/3, that's just the coefficient. And then we subtract 1 from the original exponent. So 3 minus 1 becomes 2, so t squared. So the second function, we bring down the 2, so that becomes 2 times 2 for t. T squared becomes t. 3t becomes 3, and then 2 goes to 0. So if we clean this up, we're going to get t squared minus 4t plus 3. Now, once we have our acceleration function, we're trying to find the time when acceleration is 0. So we're going to replace a of t with 0. We want to find out the time when acceleration is 0. And we can factor t squared minus 4t plus 3 to be t minus 3 and t minus 1. And we solve for t, we get 1 and 3 seconds. Okay, part B, find the velocity when acceleration is 0. So we found the time, but now we want to find the velocity. So we need to plug the 1 and 3 into the velocity function, right? Here, this is the time when acceleration is 0, but we want to find the velocity at this particular time, and those times will be at 1 and 3. So we plug 3 into the velocity function, and the velocity function is what's given to us. So replace every t value with 3, and that will work us all the way down to 9 minus 18 plus 9 plus 2, which is 2. Also, acceleration will be 0 when t is 1, so we plug 1 into the velocity function as well. We get 1/3 minus 2 plus 3 plus 2, which is 10/3. Okay, number 2, the position function of a particle moving in a straight line is given by x of t. Okay. When is the particle at rest? So particle at rest, okay, so this is saying when is a particle not moving? And another way to think of that is a particle is not moving when the velocity is 0. So that means we need to find the velocity function, set the velocity equal to 0, and then find the time. So we are given position functions, so we have to find the velocity function using power rule for each of these terms. So 3t squared minus 18t plus 24 minus 0. So that's the velocity function. I'm going to set this equal to 0 because I want to find out the time when velocity is 0. When velocity is 0, that is when the particle is at rest. So factor out the 3. We get t squared minus 6t plus 8. Continue factoring, t minus 4, t minus 2. And when we set that equal to 0, we get 2 and 4 seconds. Okay. And part B says, at what time is the particle moving to the right? So we talked about how this is particle motion. Everything is going to be on the horizontal line. We know the critical points. The critical points is going to be where the particle is at rest. Particle is at rest at 2 and 4 seconds. And here it says that this problem starts at 0. So we're going to have 0 here as well because we're not going to be including any value to the left of 0. Okay, to determine whether the particle is moving to the right, we want to figure out when velocity is going to be positive. Okay, so when is velocity going to be greater than 0? So we can just choose values in these intervals and plug the given value into the velocity function and then just test to see whether it's positive or negative. If it's positive, it's moving to the right. If it's negative, then it's moving to the left. So I'm going to plug 1 into the factored form for my velocity function. So if I plug 1 In for t, I get 1 minus 4, which is a negative value. And if I plug 1 in for t here, 1 minus 2 is a negative value. So I don't really care about the value. I just want to know whether we get a positive or negative. So negative times negative, a negative times negative gives us a positive. Here I'm going to test 3 seconds. So plug 3 into the velocity function again. 3 minus 4, that's a negative. 3 minus 2, that's a positive. So negative times positive is a negative. I'm going to test the value to the right of 4, and I'll just choose 5. So plug 5 into time, in for t. So 5 minus 4, that's a positive value. Plug 5 in for t. 5 minus 2 is positive value, so positive times positive is positive. So we know that the object is going to be at it's going to start off at 0, and it's going to move to the right. Here it's going to stop, change direction, move to the left, stop, and then move to the right again. So during what time interval is a particle moving to the right? We just read our sign line. So from 0 to 2, and then from 4 to infinity. During what time interval is a particle moving to the left? So left is negative velocity, so from 2 to 4. All right, number 3. Given the function f of x equals x over x minus 3, find the equation of the tangent line to the curve at x equals 4. Now, if we want to find the tangent line equation, what we need is we need the point and we need the slope. Now, if we want to find the point, that's simply as easy as plugging in the x value into the original function to find out the y value. So if I plug 4 into the original function, I get 4 over 4 minus 3, which is 4 over 1, which is 4. So my ordered pair is just 4, 4. Now, if we want to find the exact slope of the tangent line, we need to go through a derivative because we have a curve, and with a curve, we're going to be getting, the slope is going to be ever-changing depending on the x value. So we need to find the derivative. Here I have a numerator and a denominator with variables, so I'm going to have to go through quotient rule. And quotient rule says f prime g minus fg prime all over g squared. So I'll just follow those steps. F prime is the derivative of the top, so x's derivative is 1, times the original denominator, so f prime times g, minus f function, so that's the top function, times the denominator's derivative. So x minus 3's derivative is simply 1. So this is f prime g minus fg prime all over g squared. So g squared is just the denominator, and we take that and we square it. So if we clean this up, we're going to get x minus 3 minus x all over x minus 3 squared. The x's cancel out. We're left with negative 3 over x minus 3 squared. So here is our derivative function. Remember, a derivative function is simply a slope finding formula, and we want to find the slope at this x value. So we plug 4 into the derivative function, and we're going to get negative 3, stays up on top. There's no variable to affect that value. And then we plug 4 in for x. So 4 minus 3, quantity squared, will be 1 squared, which is 1. So we get negative 3 over 1, and that's a negative 3. So our slope is negative 3. Our ordered pair is 4, 4. And we just plug in the point slope. Y minus y sub 1 is equal to m times x minus x sub 1. Part B, find the equation of the tangent line to the curve where the slope is equal to negative 3/4. So this is a little bit different here because we want to find out, we're not given the ordered pair, we're not given the x value, but we do know that the slope we're after is negative 3/4. So if we know the slope, then we can use the derivative to help us find it. It's just that now, rather than plugging in the x value to find the slope, now we're going to have the slope and we're going to go backwards. We're going to try to find the x value where this slope occurs. So here's our derivative function. We set the derivative equal to the slope. We want to find out when or where on the graph Okay, where on the graph is the slope going to be negative 3/4? So we set the slope equal to the derivative. Here I can do cross product. The negative 3's will cancel out. I'm left with cross product here, and then negative 3's will cancel out. I can expand and subtract 4 from both sides, and then I can factor. So I get x minus 5 times x minus 1. So I get 1 and 5 as the x values where, so these are the points where the graph will have a slope of negative 3/4. So that means there's going to be two tangent line equations. There's going to be one at 1, and there's going to be another one at 5. So we have the slope, we have the x values, now we need the y values. So we plug 1 into the original function. So the original function is x over x minus 3. So then we get 1 over 1 minus 3, which is negative 1/2. If I plug 5 into the original function, I get 5 over 5 minus 3, which is 5/2. So my ordered pair is 1, negative 1/2. My second ordered pair is 5, 5/2. Both of these ordered pairs are going to share a slope of negative 3/4. So here we have two tangent line equations. Okay, y plus 1/2 equals negative 3/4 x minus 1. And then y minus 5/2 is equal to negative 3/4 x minus 5. Okay, number 4. Given the cube root of x times 1 minus x cubed, find f prime. So here we want to find the derivative. Notice that we have two separate functions. So I'm going to find the derivative using the product rule. I'm going to treat this like f of x. I'm going to treat this like g of x. And I'm going to go through product rule here. So f prime g. So the derivative of x to the 1/3 is 1/3 x to the negative 2/3 times the original g function plus the original f function times the derivative of g. So the derivative of 1 minus x cubed, 1 goes to 0, negative x cubed becomes negative 3x squared. Okay, if we clean this up, we're going to get 1 minus x cubed over 3x to the 2/3 minus, this becomes 3x to the 7/3. The way we can combine these two x's together is when we multiply bases, we add exponents. So 1/3 plus 2 is the same thing as 1/3 plus 6/3, which is 7/3. And now we can just write, so here we said we have our derivative. We can leave it in this form, or we can convert it back to radicals. Actually, we could have avoided product rule. We could have distributed this through, and once we get rid of the parentheses, we could have just went through product rule separately for the first term x to the 1/3, and then for the second term x to the first. Okay. All right, so let's look at number 5. Here we have a function that is separated by a plus or minus for each term. We can apply power rule for each. There's no need to expand. There's no parentheses in the problem. However, we do need to set each of these terms up so that they are ready for the power rule. Okay, remember, with power rule, we have a couple of restrictions. First is we need all the variable to be sitting up in the numerator. And second, we want to convert all the radicals to be rational exponents. So my first step, I'm going to rewrite, make sure each term is ready to be ready for the power rule. So here, this term is not ready yet. I'm going to bring the x up to the top. I'm going to convert the rational radical to be a rational exponent. So this will be 2 over x to the 1/2. We bring the x to the 1/2 up top. We get 2x to the negative 1/2. 4th root of x becomes x to the 1/4. The x is already in the numerator, so we're good there. 12x cubed, I'll leave that alone. That's ready to be for the power rule. 4 pi is ready for the power rule, and 6.5x is ready for the power rule. So here, every term is ready now for the power rule to be applied. So first term up, we bring down the negative 1/2. Coefficient stays. Subtract 1 from the original exponent, so negative 1/2 minus 1 is same thing as negative 1/2 minus 2 over 2, which is negative 3/2. Okay. Next term, bring down the 1/4, so 5 times 1/4, x to the negative 3/4, so subtract 1 from the 1/4. 1/4 minus 4 over 4 is negative 3/4. 12x cubed, bring down the 3, so 12 times 3 is 36. X cubed becomes x squared. 4 pi, gotta be careful here, pi is not a variable. So this is 4 times pi will remain a constant, and we know a constant's derivative will go to 0. Okay, 6.5x, this is a linear function. So 6.5x will just turn into 6.5. Okay, now if we clean this up some more, we're going to get negative 1 over x to the 3/2, 5 over 4 x to the 3/4, 36x squared, the 0 goes away, and then plus 6.5. So you either leave it in this form, or you can convert it to convert these rationals back to radicals.